Okay, cool. Okay.
I don't know if it's the previous one or this one, but
Probably the previous one and then stop or something.
Okay. Now, well, we are, I think, done redirecting. Awesome.
okay, cool.
Now we're live. Cool.
I
We
don't know if
managed.
it's the previous one or this one, but
Probably the previous one and then stop or something.
Perfect. Well, we are, I think, done redirecting. Awesome.
okay, cool.
Okay, there we go.
Cool.
Now we're live. Cool.
I
We
don't know if
managed.
it's the previous one or
Probably the previous one and then stop or something.
Perfect.
What?
I
Okay.
think it's Lily, the microphone.
All right. I hope it still works. I am admitting other people. So, okay. Hi, YouTube as well. Now we managed. Hi, welcome everyone to the first Neuroccino in February. We are, live on YouTube. Hello, YouTube. I hope it works. This is our weekly journal club. Every Monday, 9:30, we are presenting, one of us is presenting an exciting piece of science. The only rule is that it can't be your own work, but everyone else is very welcome to join and present anything that they got excited about. A tweet, a book. Usually we have a paper because we read a lot of papers. And today it is Marcella who is presenting. She is a postdoc in Bordeaux in the PCB lab. And I don't know what she's presenting, but it will for sure be cool. There is a link in the chat. And if you want to take it away, then there you go.
Thank you. So yeah, I just shared the link of the paper I'm presenting on the chat. I will share my screen. It's this one, I guess. Can you see my screen? Yes? Cool. So the paper I am presenting today is of the group of Alfred Advanter in Germany. This is white matter plasticity during the second language learning within and across hemispheres. At some point when I was reading the paper, I had the idea that maybe someone already presented the paper, but I think it's the same data set that was used for a paper that Eduardo presented maybe at some point in Neuroccino. But yeah, you will see. So this is a longitudinal study in which they explore what happened in the white matter in participants while learning a second language. So they did this study with people that were Arabic speakers. And these studies in particular to explore what happened when adults acquire a second language. So this group of people learned German for 6 months. And so let's see what happened, what they did. So at first they provide a context of what have been done before in different studies exploring gray and white matter during learning or acquiring a second language. And the basis of this study is that there is a model that is the dynamic restructuring model that proposes that there are 3 different phases of structural adaptation when people is learning a new language. So first, there is this earliest phase where there is only changes at the gray matter areas. And then there is a second phase, an intermediate, that is related to a consolidation phase, where we can observe some changes at the level of the white matter, where these changes are in particular in areas that are related to language. And then in the last part, there is this peak efficiency phase, where this model predicts that there are more changes in the brain structure, and in particular that there is an increase in the connectivity in the white matter at the frontal level. that will allow this proficiency in the second language. However, besides these different studies in people where they learn a second language, there are no studies that explore what happened in these different phases. So also what they report is that at behavioral level, usually it's more like it's simpler to learn so some simple aspect of the grammar of a second language as an adult. But then in the last part of the learning, where you have to learn more the syntaxes of the second language, these are more difficult, and usually people don't arrive to this level of learning. But at the neurofunctional level, they have reported that there are less overlap in the brain activations when exploring the first and the second language in people when they are just starting to learn a second language. However, what you can see when people is really proficient in the second language is that they recruit additional areas in the right hemisphere of the brain. So what else? They also report that there are some studies that have explored what happened when people learn this a second language, and they have reported changes in the gray matter, and in particular in these areas that they report in bilateral inferior frontal gyrus, inferior parietal lobe, and anterior and posterior temporal lobe, and in particular in areas that are related with language. So I'm going to, the last important point is that also in several studies report that there is an important role of the corpus callosum when learning a second language. However, there are different theories that one of them proposed that there is a role of inhibition between hemispheres, in particular between the left on the right. And another theory that proposed the opposite, where there is an excitatory role of the corpus callosum from the left side to the right side. So based on all these previous studies findings, they try to see what happened in reality in the brain when people is learning this second language. So they explore what happened in a group of healthy Arabic native speakers and who went to a course to learn German for 6 months. So they explore a baseline where they did a test of German, and also they have a MRI. And then after 3 months that they call this initial beginner phase, they again explore behavior, so test in German and also a second MRI. And then in the third level, after 6 months, they also assess the level of the second language and also another imaging acquisition. Okay, so I'm going to the results of this study. So what we can see here in the figure 1 is in A, we can see the difference in learning the second language between at the end of the 3 months and then at the end of the 6 months. And we can see that all participants actually learned this second language in a good level. And then in figure 1b, we can see that there is a relationship or a correlation between the level of vocabulary of people in this second language and the overall result of the test in German. So they explore the writing, the oral, reading, and so there was this relationship between the total score in the test and also the level of vocabulary that participants managed in the second language. And then they explore what happened at the brain level. So in particular, they focus in the white matter and in the different regions that we can see here that are related. They call the language networks that involve the inferior frontal gyrus, temporal lobe, inferior parietal lobe, the anterior and posterior corpus callosum. And in A, you can see the areas that they explore. And then we can see in B the difference in the connectivity within each hemisphere in the different time points. So we can see that in the 3 time points, there is a higher connectivity in the left hemisphere compared to the right hemisphere within these networks that I show here. So in the regions that they in particular focus. And we can see that this relationship of connectivity between the 2 hemispheres didn't change across the time. But then when they explore the connectivity at the interhemispheric level, what they observe is that there was a decrease in this connectivity between the across time. Else here you can see that at first there is no difference, but then you can see that there is difference in this connectivity. This connectivity is the comparison, the connectivity between the corpus callosum and each of the regions in the left or the right hemisphere. So what they explore then is, okay, so they look at what happened in the network in general, but now what they explore is that which are the sub-networks in this network that actually increase or decrease in connectivity during the different learning periods. So at first they explore between the changes between the baseline, so the first, before starting the course of the second language, and the 3 months. And what they observe is that there are only a few sub-networks that have changes. And here I have, so in particular, they observe a decrease in the interhemispheric connections in the sub-regions of the inferior frontal gyrus and in part of the right arcuate fascicle. So here we have these changes only in the right hemisphere and these between hemispheres. And what they observe that most of the changes occur in the second part, so between the 3rd month, so the initial part of the learning, and the 6th month, so when they actually reach this proficiency of the second language. And what they observed was this increasing connectivity in 3 subnetworks, including these bilateral parietal temporal networks, and in the arcuate fasciculus in the right hemisphere. Here we can see below. And here in the right, what we can observe is that there is a decreased connectivity in this second period between in the connectivity between the hemispheres that are here reported in with the blue colors. So in all these figures, the increase in connectivity are with the red, and the decrease are shown with the blue colors. And at the end, what they explore is which of these areas that show these changes across time were correlated with the behavior. And what we can see here in the figure 4 is that these areas, with that, again, with same color code, we can see that there is a positive correlation between the proficiency in the language, so the results in the test, and the connectivity in this subnetwork connecting the posterior temporal and the inferior parietal lobes in both hemispheres, and also in the right arcuate fascicle in the right hemisphere. And as a negative correlation, what they observed is that there was a negative correlation between the the proficiency in the second language and in these changes in the interhemispheric connectivity. And just that these changes that they measure and that correlated with the behavior were the changes that they observed in the second period of the learning period. So in between the 3 months and the 6 months of the course. So these are all the figures in the paper, and so what they conclude from this study is that there are some changes that occur in the white matter while adults are learning a second language, that these changes mostly occur in the second part of the learning when they are more proficient in the second language, and that these adaptations seems to be mostly in the lexical semantic system, and particular in the temporal and temporal parietal regions, with increased connectivity in both hemispheres. But at the same time, they report this important role, I'm going back, in the right hemisphere. And what they support with these results is that there is an inhibitory role of the corpus callosum from the left hemisphere to the right hemisphere when people learn a second language and actually use this second language. Also, they report some limitations, of course, of the study, and in particular, the variability between the subjects, as they found some correlations between the level of connectivity at the functional connectivity level, because they also explore functional connectivity, and the learning proficiency. And also some variability at the baseline of the connectivity. Where is that? Because they observed that the frontoparietal anatomical connectivity actually predicted the individual proficiency of the learning of the second language. So they report that future studies should consider this difference at the baseline, so during the first MRI, to be able to also report more accurately what happened in these changes in the white matter with the plasticity. And I think that's all. And yeah, again, they also report that there is this strong involvement of the right side of the brain when people are more proficient in a second language. And yeah, that's all. Happy to answer some questions if I can, and to receive comments about the paper.
Thank you very, very much, Marisa. The first hands are up. We haven't had that many hands up since a very long time. I think Eduardo was the first one, so go ahead.
Yeah, thank you, Marcela. Very interesting paper on second language learning is always interesting. I have a couple of questions, but first of all, these are not the same that I presented months ago or so. It's still by Angela Friederici, but it was just German native speakers back then.
Okay.
So yeah, my first question is how do they define connectivity? What kind of measure Did they use fractional anisotropy geometry of the tracks for
Yeah. So here at the connectivity, they use the strength of connectivity within these networks, but they retain only the 30% of the strongest connection. And what they use as a measure, I think it's in the, wait, I think it's in the supplementary material. I have here the supplementary material. I don't know if you can see. Here. Yeah, using a probabilistic cartography. And yeah, in the threshold is where they mention different threshold they use, and at the end they keep only the strongest connection, but I not very familiar with the techniques. I'm not very.
Okay, thank you. It was just to have a clearest idea. My second question is, you mentioned that they link this change in the connectome to lexical semantic processing mostly, right?
Yeah.
And I was wondering why they're arguing this is the right conclusion. Is it due to the experimental manipulation, or are they inferring this conclusion from the results?
Yeah, they infer this conclusion from the results, and mostly it was because of the regions they found that change in the second part of the period of learning, so between the 3 months and the 6 months. Yeah, they mentioned that these areas are mostly related to lexical, semantic, and phonological processes, and I think it was also the role of the right hemisphere, but not sure.
Okay, thank you.
But yeah, mostly because of the results, the regions that they found that has this plasticity during the learning in the second part of the training of the second language.
Okay. Thank you very much.
Thanks for the question. I believe Chris was next in the queue. So Chris,
Thank you for presenting. Have you seen other studies on learning that are involving the right hemisphere? Like it seems to be it's a regulation. That's what they say, right? Because there is either inhibitory activity on the network of language. Yeah, is there any other cognitive functions that have been studied in the same way, like when you're while you're learning it, seeing the same kind of pattern from the right hemisphere?
I don't have, I'm not familiar with any study about learning or that explore different cognitive functions regarding this. But yeah, I don't know if it seems that in language it has been explored and has been observed in other studies. But I don't know if using other cognitive functions it has been shown the same.
Because the right hemisphere, I don't know if these, I'm not very good in anatomy, and you're better with functional networks, but there is in the right hemisphere, we see it often with the control functions, So that makes sense with the regulatory effect. So that would also make sense to use this control on other mechanisms when you're learning. Not necessarily. So here is the lexic that is regulated by the right hemisphere, but for another kind of task that you're learning, it could also involve the same kind of network, no?
Yeah, I agree. I would say that yeah, they can be involved in learning not only language, but I don't have in mind any study about that. But yeah, I agree with you that the role, I don't think it's only important for learning language. What it mentions actually is that the this like the role in this case of the corpus callosum is to allow in the brain hemisphere to also activate the same homologous regions that are being activated in the left hemisphere. So probably it's like the right hemisphere needs to, or some regions of the right hemisphere also are being not activate, but yeah, that actually also play the same role while you learn something, some cognitive function. But yeah, I don't have in mind any study. I don't know if someone can report, but at least here they mentioned that in different studies involving learning a second language, the right hemisphere has been shown to have an important role. But yeah, I would say yes for other cognitive, other not only language, but I have nothing in mind now.
Thank you.
Thanks, Marcia. We have time exactly for one more question. So, okay, two more. No, it's going to be two. Go ahead, Lily.
Actually, three, because I have two questions. So maybe I will repeat actually, Eduardo. So the title of this paper is White Matter Plasticity, right? But I had an impression that the paper was mainly about functional connectivity. And even though they do probabilistic tractography, I didn't get what exactly has changed. Is it track count increased? That's how we got the plasticity idea, that there are changes. What is structurally is actually changing?
Yeah, what they explore in the at the three different points is using these network-based statistics. So what they take is the I can show you the matrix of connectivity. So here they have this matrix of connectivity that you can see here in the figure, and they use this as an input in the three different periods. And what this network-based statistic does is that compare the different connectivity within and between regions in the matrix. So it's the comparison actually is statistical differences in the connectivity across time, but I'm not very familiar. I know that this is the network-based statistics is actually to compare if there are differences in the networks, and it's very used in functional connectivity. So I would say this is the same, but of course analog for this structural data. And what it does is it's compare the different edges, so different connections in the different points, considering that these are networks and the different connections. But it's a statistical comparison.
So technically, they can't say exactly which tract changes.
Yes.
So it's general situation within that hemisphere is changing, but we cannot say that this is accurate.
Yeah, they can, because they, and maybe it's my fault, sorry, I didn't say, but as they use these different definition of regions, as you can see here.
I know, yeah, you said it. Yeah.
You have the different regions and the connections.
Okay. And the second is about the inhibition of corpus callosum. So, as maybe also Eduardo mentioned, this is not experimental setting, right? So, is there actual evidence that there was inhibition, or just inhibition because it requires like some action from corpus callosum, while we see only reduced interhemispheric connectivity? Doesn't say that it is inhibiting something, no?
Yeah, I agree.
I
The
think in
conclusion,
the abstract, it was something interhemispheric.
yeah, here is exactly
The
yeah,
reduced
because
Mhm.
exactly because they observe this reduction of the interhemispheric. Do you remember the blue
Mhm.
track? Right. So this is the reduction, the decrease of the in the interhemispheric connectivity, and they suggest that yeah, this can support this inhibition role of the left hemisphere dominant for language into the on the right hemisphere, based on only in these two theories. The theories I mentioned, that one that support the inhibition from the left to the right, and the other one the excitation from one side to the other. But yeah, the conclusions is due because of this decrease in the connectivity. But yeah, it's based on the results. But they didn't explore if there is like directly inhibition or excitation. But
Yeah. Okay, thank you.
All right, we need to move forward and we need to move on because we don't have that much time left. Actually, we're already overdue, but Sabrina, go ahead.
Thank you. And thank you for the presentation. I was thinking, yes, I move a bit the attention to the behavioral part. So, do we have information about the behavioral part? So the task, the language,
yeah,
exercise, and these.
Yeah,
Because,
actually,
yeah,
yeah, it's like a typical course with the different levels of proficiency in the different language. So A1, A2, B1, B2, and it was a course of 600 hours in which they had also tests in the different listening, reading, speaking, and writing. So it was in all the different areas of the language.
okay, these points. And did they test also the memory, maybe? Or no? Only language?
No, they
Because...
only did an extra test of vocabulary.
Okay.
But yeah.
Oh, okay, it's focused on language. Thank you. Right.
Yeah.
Right, we need to take the last question. Ami, go ahead and yeah.
Yeah, so just quickly, I mean, I'm kind of going over the same points that others have raised between what they mean by connectivity and the relationship with excitation and inhibition. And so looking at the supplemental material, I think their definition of connectivity is the relative number of streamlines, right? So it's interesting that they got the results they got, but I really wonder what the biological substrate of the changes they observed is, because that means they observed some decrease in the streamlines between, two regions, or increase in the streamlines. And when you think about inhibition or excitation, you would think that, I understand if it was a functional connectivity that increased or decreased, because that can suggest inhibition or excitatory mechanism. But for either inhibition or excitation, the the actual connection has to be there to inhibit or excite the other parts, right? So I don't really understand why the streamline counts would have to increase or decrease, and what the, you know, in terms of the biological underpinnings, what does it mean? Like, does it, you know, does it mean that some connections are disappearing? It seems kind of a stretch to think that in the short time scale that it can happen. Like, I don't know if myelinations can decrease in the short time scale as well. So like I'm a bit surprised, and I wonder what, like, it's easy to say decreased connectivity. I mean, if this is a functional connectivity, I feel I can understand a little bit more their interpretation. But if they're counting as streamlines, I really wonder what their interpretation of like a biological mechanism that's happening in this time scale.
Yeah,
I don't know if you can answer questions.
Yeah, I don't think I can answer, but what they mentioned is that as a language is very left dominant, and that this decrease in this connectivity between the left and the right, it means that the right hemisphere possible has less inhibition, and it's engaged in this proficiency or in this learning of the second language. I don't remember that they mentioned something. They don't actually, no, they don't conclude something about the biological aspect or what happened with this decrease. They all attribute to the inhibition from one hemisphere to the other. But yeah, I don't think I can answer, and I don't think there are something in the paper in my knowledge as I remember. But yeah, at some point I saw something about myelination, but I think it was in the introduction when they report all previous studies, but not in the conclusions. But yeah, so yeah, I'm sorry.
But thank you.
All right. That's yeah, we're coming to the end of this Neuroccino this Monday. So thank you very much, everybody, for joining in and participating and all the questions. Thanks, Marcella, for presenting. We see each other next week, 9:30. So same time, also Monday, and I'm not sure what's happening here now. So yeah, have an exciting week in science, and see you next week.